Hello students, today we'll discuss IB Physics HL Paper 1 May 2018 Time Zone 2. In this paper you cannot use calculator. My name is Nariman Melim. I'm located in Baku and here you can see my mobile and email. How to prepare for exam. Main huge textbook is from Oxford 2014. Shorter textbook is from Tim Kirk, Oxford 2014. And when you prepare for exam, you should have 1. IB Physics Guide 2016, which describe exam syllabus and mentions the formulas that are in a booklet. What is this booklet? It is number 2. What you should have: Physics Data Booklet, First Assessment 2016. In this booklet you have data and also formulas. This booklet should be available for you at exams. This is the cover page. So exam lasts for 1 hour, 40 questions, 40 marks, and you should have clean copy of Physics Data Booklet. Question 1. What is the best estimate for the diameter of a helium nucleus? Memorize: diameter of nucleus is about 10 minus 15 meters, so answer C. Question 2. A motor of input power so much raises a mass vertically at constant speed. What is the efficiency of the system? From section 2.1 of data booklet, efficiency equals useful power out by total power in. To raise at constant speed, we apply force equal to weight, so force will be mg. One of the formulas for power is force times velocity, so instead of force we put mg, so we get mgv. So this mgv goes to numerator, in denominator we put total input, and calculation give us 25%. A box is accelerated to the right across rough ground by a horizontal force, which is the free body diagram of the situation. Because box is accelerating to the right, vertical forces should balance each other, so it is either C or D, and because it is accelerating to the right, Fa should be greater than F1, so resultant force should be to the right. So answer D. The graph shows the variation with time of force acting on an object. The object is at rest at time 0. So area under this graph equals to impulse or change in momentum. So area under the graph equals change in momentum. Area of triangle is half height times base. Height here is F and base is T. And change in momentum is mv minus mu. U is 0, so we are getting formula for v. We solve it for v, and answer is B. A ball of mass m is thrown with initial velocity u at angle theta to horizontal as shown. Q is the highest position of the motion, resistance is negligible. So when we throw ball at angle theta with u, it has horizontal component, which is according to trigonometry u cosine theta, and vertical component which is u sine theta. As it goes up, vertical component decrease and reaches 0 at the top. The horizontal component doesn't change because no force is acting and air resistance is negligible. So here velocity is u cosine theta multiplied by mass give us momentum, mu cosine theta, so answer B. Here a ball starts from rest, and if we look time interval between this position is 1 milliseconds. What is average acceleration? Assuming constant acceleration, we use from section 2.1 we should choose formula. So we know S, we know time, 5 times 5 time intervals, 6 positions by 5 time intervals. Each is 1, so total is 5 milliseconds. U equals 0, A question mark, no V. So no V formula is this formula. This formula simplifies dramatically when u equals 0, and solving it for A, we get answer B. A ball of mass m collides the vertical wall with the initial horizontal speed u, rebounds with horizontal speed v. The graph shows the variation of speed of the ball with time. What is the magnitude of the mean net force on the ball during the collision? The trick here is that graph is for speed, but we need velocity. So force equals change in momentum divided by time. Time interval is t2 minus t1. At t2 we have momentum mu, and this is initial, and final velocity is minus v because it moves in opposite direction, so it is minus v minus mv, and change in momentum will be mu minus minus mv, mu plus mv, and answer D. Question 8. The graph shows how the temperature of a liquid varies with time when energy is supplied to a liquid at constant rate P. The gradient of graph is K, and the liquid has a specific heat capacity C. What is the mass of the liquid? From section 3.1 of booklet, energy is linked to temperature change. From graph, which is the graph of function y equals mx plus c, c is y-intercept, and m is gradient, t equals t0 plus gradient times t. So delta t equals gradient times t, and delta t by time equals, actually it is gradient, so it is k. Dividing both sides of main equation by time, on the left we get rate of supplying energy, and on the right we have cm and gradient of the graph k. So we put p and k and solve for m, we get A. Here we have two valves. They have different volumes and different pressures. The valve is open, temperature doesn't change, so part of the molecules move from high pressure to low pressure. Let's assume that in the end we have pressure X. What also didn't change is the number of moles. The total number of moles stays the same. Before, from section 3.2 we have ideal gas equation where we have number of moles n. So in Q we have nq moles, in R we have nr moles. Total number of moles is 6 PV RT. After opening valve, nq we find from this formula, and p we find from this formula, so total is this. So total expression, this expression is equal to this expression. We solve for x, and now we can find the change of pressure for V. Final minus initial. Final is so much, initial was P, so answer plus P over 2. Question 10. The sound waves from a point source on the ground travel through the ground to a detector. The speed of one wave is so much, another wave so much, time difference 15 seconds. What is the distance from the point source to the detector? Time is for constant speed is distance divided by speed. Let's call distance x, then time 1 will be x over 5, time 2 will be x over 7. 2 difference will be this expression, and we can find x, so it is d. Using arithmetic you can find that this d. What is true about acceleration of the particle that is oscillating with simple harmonic motion? So here I have drawn equilibrium position, so particle oscillate, stops, then maximum speed velocity, then stops, and acceleration in the middle 0, at the extremes it is maximum. It is in the direction opposite to the velocity. No, for example here they both are to the right. It is decreasing when potential energy is increasing. Potential energy increase with displacement, the same happens with acceleration. It is proportional to the frequency of acceleration. No, according to 9.1, acceleration is proportional to square of frequency. It is a minimum when velocity is maximum. Yes, if one is sine, another is cosine. For example, here velocity is 0, acceleration maximum. Here they ask, so here velocity is maximum, acceleration is 0, which is minimum. What are changes in the speed and wavelength of monochromatic light when the light passes from water to air? So from water to air, speed increases and wavelength is proportional to speed according to wave equation, also increases. So increases, it is A. Question 13. A string stretched between two fixed point sounds is second harmonic as F. So second harmonic is here shown. First harmonic will be from here to here. Which expression, where n is integer, gives the frequency of harmonics that have a note at the center of the string? Because this harmonic should have, so this end is fixed, we can forget about the rest part and we can consider this as a string with frequency f. Here it will be, for this string it will be fundamental frequency. And we can use standard formulas which are not in the booklet. I recommend you to copy this formula. So formulas of harmonics where n equals 1 is fundamental. So we choose answer B. So what changes occur in ammeter reading and in the voltmeter reading when resistance of variable resistor is increased? So variable resistor and fixed resistor make here potential divider. They share voltage provided by cell. The greater the resistance, the greater share of voltage is on resistor. So when we increase resistance variable resistor, more voltage falls on it, but total resistance will increase, decreasing the current. So we choose ammeter decrease current, but voltage increase. Answer C. Electron enters the region between two charged particle plates, initially moving parallel to the plate. Electromagnetic force acting on the electrons A and B decrease, increase horizontal speed. This is wrong because the forces act at 90 degrees to the direction of the electron, so it doesn't affect horizontal speed. Is parallel to the field line and in opposite to the direction to them. Yes, field line shows the force on positive charge, so on electron it will be in opposite direction but still parallel. Perpendicular to the field, it is wrong, so answer C. What is the current in resistor X? So 6 ohm and 6 ohm are in parallel, so we use formula for in reciprocals and we will get 2 times less. So instead of these two resistors, we can imagine one resistor, 3 ohm. 3 ohm and 3 ohm in series we should add, we are getting 6 ohm. Cell is EMF 6 volt divided by 6 ohm give us 1 ampere, so answer C. Object move in a circle, what is the rate at which work is done? As centripetal force is at 90 degrees to velocity and displacement, work done is 0. So work equals Fs cosine theta at 90 degrees, cosine is 0, work done is 0. So answer D. 18. Detector placed close to radioactive source detects activity 260. The average background activity is 20. Radioactive nuclide has a half-life of 9 hours. What activity is detected after 36 hours? Here's the trick with background radiation twice. First of all, we subtract with first reading background to get activity 240 at the beginning. After 36 hours, we divide by 9. 4 half-lives pass. So this activity is decreased every time by 2, so by 16 times, 2 to the 4th. So it comes to 15. But detector will read also background radiation. So we add background and we put 35, answer D. Element X decays through a series of alpha and beta minus emission. Which series of emission result in an isotope of X? Isotope means the number of protons is the same, but number of neutrons are different. In alpha emission, number of protons and number of neutrons decrease by 2. In beta minus, one of neutron decrease and one proton increase. So let's check one by one choices. Choice A, in A decay minus 2 protons minus 2 neutrons, but 2 beta minus plus 2 proton minus 2 neutrons. So number of protons as a result doesn't change, but number of neutrons decrease by 4. So choice A. Identifies the conservation law violated in proposed reaction. For strangeness we don't have strict rules, so we check baryon 1 1 1 1 0 2 equals 2. Lepton 0 0 0 0 1 not conserved, and charge 2 2. So lepton number is not conserved, so it is B. A wind turbine has a power with speed V. Efficiency of the wind turbine doesn't change. What is the wind speed at which the power output is P over 2. So from section 8.1 we get formulas for the power. Case 1, case 2, ratio of powers is 1 over 2. Then we simplify a row, and we make cube root of both sides and answer D. So we have here Sankey diagram, input from fuel and light on the filament, which is true for this Sankey diagram. So input is 20 millimeters or 20 units, output here 11, 2, 4, 3 and 2. I checked and I found that overall efficiency is 10%. 2 is useful output, 20 is total input, so 10%. 23. Which part of nuclear power station is principally responsible for increasing the chance that a neutron will cause fission? Chance increases for slow neutrons. They are slowed by moderator, so we choose a moderator. At which position is the resultant force on the pendulum bob 0? Because pendulum moves always in a circle, we always have resultant force which is centripetal, so it's never 0, so we choose answer D. A beam of monochromatic light is incident of a single slit and a diffraction pattern forms on the screen. What change will increase? Delta S. So formula for diffraction through a gap, through a slit, is section 9.2. If we decrease B, theta will increase, so we choose answer B. 26. What is the wavelength of the light? So section 9.3, formula for diffraction, n is 1, distance between slits is 1 over n, angle theta is actually half of this angle, and we get formula D. A train is approaching an observer with constant speed. What is the observed speed and observed wavelength as the train approaches? 9.5, moving source approaching, then frequency increases. We choose formula with minus, and we get 34 33s of F. Wavelength is inversely proportional to frequency, so it is increased by 33 over 34. Speed doesn't change, so we choose answer A. So here we have two objects. What is the distance from the center of planet at which the total gravitational potential has maximum value? So let's choose one point somewhere here. Call this distance x. Another distance will be 22 r minus x. Potential from each of these objects will be minus gm over r. Mass is different, distance is different, so mass different, distance different. And this potential has extremes when derivative equals 0. So I find derivative and finally I get x equal 20R. Question 29. What is the work in joules done by electric field in moving negative charge 9 coulomb from the position shown to x to y? So here everything is shown for positive charge, and work done equals charge time potential difference. Because moving along equal potential doesn't change potential, work is 0. Moving from here 100, actually for negative charge it will be minus 100. Here 150 will be minus 150. We substitute values and we get positive 50 nanojoules. So how we got nano? We kept charge in nanocoulomb. So positive charge, which electric field is correct? I choose C because field lines are not at 90 degrees to the metal plate, and this is positive charge. The field line shows the force on positive charge, so outward. A satellite orbiting moves from X to Y. What is the change to kinetic and gravitational potential energy? So if we consider moving in a circle, centripetal force equals gravitational, formulas mv squared r and formula for gravitational, we see that mv squared or mv squared over 2 is inversely proportional to radius. So when you move from X to Y, speed and kinetic energy decreases. Potential energy is negative. This is why when we move away it is actually increasing, less negative, increasing. So we choose answer C. 32. Moon and Earth, find the ratio of escape speeds. So section 10.2, escape speed, ratio, mathematics, we get C. So current I is increased to induce current in B and C. What is the direction of current in B and C? So when current I increases, magnetic field at the red point and green point are increasing. The current should decrease this point induced current should decrease this magnetic field according to Lenz's law. Using right-hand grip rule, we find that at B the current should be anti-clockwise, at C clockwise. So here we have frame moving in magnetic field, which graph shows the variation with time of induced EMF in the coil and moves from P to Q. So EMF is proportional to rate of change of flux. Flux equals BA here. So when at P flux is increasing, so EMF is positive, for example, or negative, it doesn't matter. Let's call it negative. And here no change because it is the same BA. Here decreasing. So I choose A because here we have section with constant negative and here constant positive EMF. 35. So here we have power, and what is efficiency, frequency and average power. So formula for power is V squared over R, where V is root mean square, 36 watt. So because it is power, the period is 2 times greater. It is sine squared function actually, or cosine squared function. Here cosine squared function. No, sine squared function. So period is 004. Frequency is 1 over period, 25 Hertz. So combined resistance is 1.5 C, each is C, which combination give us 1.5 C. So here three capacitors in series, so we use reciprocal formula, C over 3. Here in parallel we add. Here we have in series reciprocal C over 2, and then in parallel we add C, so 1.5 C. Here photon 6 electron volt, 2 volt is stopping potential, so electrons are escaping. What is the maximum kinetic energy of photoelectrons that reaches the anode? First we find maximum kinetic energy of photon leaving cathode using formula from section 12.1. It is 3 electron volt. As they move, they are slowed down by stopping potential, and stopping potential decreases kinetic energy by QV, which is 2 electron volt. So we subtract from 3 electron volt how much they lost, 2 electron volt, we get 1 electron volt. 38. Which of the following is evidence for wave nature of the electron? I see only one wave property, diffraction, so it is B. An electron of initial E tunnels through a potential barrier. What is the energy of the electron after tunneling? So tunneling happens due to temporary uncertainty in energy. Energy doesn't change. Two samples X and Y have the same initial activity. Sample X has, I would add here now, twice the number of atoms of it. The half-life of X is T. What is the half-life of Y? Because Y has twice less atoms, its half-life is shorter, either T over 2 or T over 4. After time T, here we have one half-life and two half-lives. So N over 2, N over 4, ratio is 2 to 1. So it is correct answer C. T over 4 give us ratio 1 over 8. So paper is over. Thank you for your attention. See you next time.